So, talking converting rates, I know we have a couple examples we're going to go over from our warm-up there. But why would this be useful? Why would we need to be able to change the units on something, Tanya?
If you want to know, like, half the distance or whatever, or, like, you need to, like, if you're, let's say you're driving for an hour, right? And you know you're going to need gas in the middle. I know some of those, like, let's say you do. So you need to know, like, how fast you have to drive to be able to not run out of gas.
So something like use rates and ratios to make decisions. And you might need to change the units because one unit helps you make your decision better than another, right? Some units are so big they're hard to wrap your head around, and you can make things more manageable by just changing units, right? What's another way we would use these rates and ratio conversions? Like, think about your warm-up. Why did you change stuff in those two questions?
To know if you added it.
Easier to do what?
To do the problem.
Well, but
It was easier to live life.
What were you doing to find the answer to those questions? With two amounts,
Multiplication or division?
what were you trying to do with those two amounts? Come here. I can't hear you. We'll compare them. So easier to compare. Right? I was looking general. It makes things really easy to compare. Like, if we have things in two different units, it doesn't always just pop what's what. Like, what does it really mean? Right? In fact, I would say some things would be impossible to compare unless we got them the same. A lot like fractions, right? With fractions, we get like denominators, so we can understand what they are compared to other fractions, right? Ratios are also a fraction. So, let's talk about this Bowen and the Velociraptor. So what's the information we knew on there? You guys got your computers up in here. What was on there? How fast were they? Mikey, give me somebody. How fast was somebody?
Bowen ratio?
Yeah, how fast was Bowen ratio?
It was 7 miles per hour.
7 miles per 1 hour. So just for some like language review, what is this thing? 7 miles per hour. What? Okay, you could say MPH, but what is this in math? What is this thing, John?
A unit rate?
It is a unit rate. I know it's a unit rate because it's per hour. It's also a rate because it has two different units. And it is a ratio because it's a comparison of two things, miles to hours, right? So it's all those things when we're talking. Now, our Velociraptor, how fast was that guy? James?
11.73 feet per second.
7.3
Yep.
per 1 second. Again, we have a unit rate.
Why is the Velociraptor
Okay.
race?
11.73 feet per second. So the question is, who's faster? But the answer is, just by looking at it, I don't know. Maybe this Velociraptor only has one leg. Who knows? Okay? We don't have all the details. All right? Maybe the Velociraptor's been in captivity. They've been overfeeding it, and it's just way slow. I don't know. Jurassic Park. If you watch that documentary, you might learn something. Okay, so I have two options here to compare. What would I need to do to be able to say who's faster here? What would I need to do to say who's faster? James? Convert them to the same rate. I like how you stated that, James, because I have options. I can get this to be feet per second, or I can get this to be miles per hour. So, I'm going to let us vote. Only in class people, just to make it manageable, Zoomers. Who would like to change miles per hour to feet per second? Raise your hand.
Me.
So 1, 2, 3, 4. Who would like to change feet per second to miles per hour? Raise your hand.
that's
1,
what
2,
I
3,
meant.
4, 5, 6. Okay, this one wins. So we're going to change the Velociraptor to miles per hour. You guys understand, though, it doesn't matter which one we did. It just has to be the same.
It kind of does. I feel like miles per hour.
Except it doesn't. But, okay. I like miles per hour are nice because we kind of can wrap our head around it, I guess. But in terms of comparing, as long as they're the same. So, my goal, I'm going to write that over here. Goal is miles per hour. Now, I'm going to show you. I walked around, and y'all were doing this math that I'm about to show you. But I'm going to have you write down what I write down, and notice that the way I'm doing it shows excellent communication and organization. All right? So just follow me. Just follow me.
I can't see.
I'm going to let you guys tell me, again, an option here, because it doesn't matter what I like to set up like this. I'm changing both rates, so I'm going to multiply twice. I know that one of them is a division.
What?
Just stay with me. So I like to set up like this. I know I need to get feet to be miles and seconds to be hours. So I'm doing two things. So I set it up like this, saying like, I'm doing two things. Now stay with me. We need conversion factors here. So I don't care which one we do first, feet or seconds. Which one do you want to change first? Raise your hand for feet. I got 1, 2, 3. Raise your hand for seconds. 1, 2. Okay, we're changing seconds first now. Watch how nice this is. I have seconds and I want it to be hours. Right? I want it to be hours. No, you could go minutes, hours. There's more steps. But, so what's my conversion factor here? What's my thing that I'm looking at? Yeah, me. 3,600 seconds. Now, the number one place where students mess up is they multiply when they should divide or they divide when they should multiply. So here's the easiest way. Watch this. I know it goes up here, and I'll show you why. With fractions, when we multiply, we can cross simplify, correct? Because if something's in the numerator and something's in the denominator, it cancels. Look what happens with my units here. Seconds cancels seconds. And look at the units that are left after our word to do this. This would give me feet per hour, which has me getting close, okay? Here's another thing I want you to wrap your head around. Would you guys agree 3,600 seconds is an hour?
Yes.
So what's anything divided by itself?
1.
So it's kind of like I'm multiplying by 1, which is the reason I'm not changing the speed, I'm just changing what it looks like, right? That's why it's also called a conversion factor. So the value of that kind of is 1. It's going to change our numbers, but since we're changing our units, it's going to have a different number. But value-wise for speed isn't changing. So does everybody see how that can help you know to multiply? My seconds cancel with cross simplification. So now I'm at feet per hour, but I want miles per hour. So I need another conversion factor here. And if I want feet to cancel, where does feet need to go in my next fraction that I'm multiplying by? That has to go in the denominator, right? And I want it to be miles. So I'm using this before even setting up a conversion factor. These are the units I would need to do. And 1 mile is 5,280 feet. Now watch what happens with my units for feet. You ready? This one cancels this one. And look what I'm left with. Look what I'm left with. Miles per hour. I'm left with miles per hour. So when you do it to it, 11.73 times 3,600 divided by 5,280, we get just about 8 miles per hour. Which means winner, winner, chicken dinner for that velociraptor.
Yeah, we already know we haven't.
Let's talk about those beans. I had, help me out, 32-ounce beans cost how much? Was it $1.75?
Yep.
And 1.5 cups of beans cost 54 cents. Okay, so we need to figure out how much this costs. I'll let you know, the number one thing I see students do wrong when they're doing price per comparisons is they take the thing and divide by the money. But if you use the words price per, what should be your numerator? The money, right? So we have options here. Do we want price per ounce or price per cup? Let's take a vote. Who wants to do price per ounce? Okay, that looks like it wins. We don't even have to do that. Okay, so we'll do price per ounce. So for the 32 ounce of these beans, the price per ounce is $1.75 divided by 32. I get 0.055 per ounce. Okay. So the other side, I don't know what's up because it's not in ounces. It's only in cups. So here's what I'm going to do. I'm going to use that conversion factor skill that we just practiced. Okay, so I'm going to just change cups to ounces. How many ounces in a cup? 8 ounces. So I know I need cups to go down here and ounces to go down here. 8 ounces, 1 cup. And the reason I know cups needs to go in the denominator is I need that to cross simplify my units, right? So if there's ever conversion, do I multiply or do I divide? This makes it happen. And that gives me 12 ounces. So price per ounce, 54 cents, divided by 12, I get 0.045. So 4.5 pennies per ounce instead of 5.5 pennies per ounce. What's the better deal? The 1.5. I'm going to have to just buy a bunch of little cups. All right? That's the better value per ounce.
Only by half a cent.
No, yeah, a cent per ounce. So it depends how many beans you need, how much you're going to save. 32 cents on the 32 ounce.
If you buy a bean of those.
Yeah. And here's the deal, 32 cents when you're talking about something that little, that's a big percentage savings.
The best thing to do.
Right? Big percentage
The
savings.
best.
Big idea. Big ideas I would say to write down here. Because I can't show you every type of conversion problem.
Yeah.
Stay organized. You don't have to write this down.
I'm going to.
Use units in your work. And get units to cancel. Did I just spell cancel now? That feels right. Okay. If you do those things, every conversion problem is open to you, right? I can't show you every type of thing. I also will give you the conversions. Now, if you're doing homework and there's some crazy conversions, look up like if it's cups and ounces, look up how many ounces in a cup. Don't go look like, if it's like gives you like 3.6 cups, don't write like how many ounces in 3.6 cups, because that will not be an option on a test, right? Now there's two things here. I know Google can just give you answers like that. But I need you to practice the things like the number sense pieces, right? The computation pieces as well. I'm not just assessing, do you get the right conversion at the end, right? So just make sure, stay organized. Again, this is like one of the harder ones we would have to do, feet per second to miles per hour. And look how like tight that work is. Easy to follow. You won't get stuff mixed up. So focus on that organization. Use units in your work. All right, circle things, box things in your work to keep track, because that's where things go wrong in these. Is like you lose track of where you were or what number was what. All right? Okay. So on your homework tonight, it's on Go Formative. You're going to start at question number 13. All right?
Do you